that happened 3 years ago, or the Nipah virus outbreak in Kerala in 2018. Each one of them, when it happens, it catches us by surprise. It leaves us perplexed with a sense of despair. Our next speaker is a physician, a scientist, and has been internationally recognized for discovering viruses that cause deadly diseases in people and food sources that threaten India's food security and food security across the world, of course. He's worked with several governments of different countries. He and his team implicated the West Nile virus as the cause of the encephalitis epidemic in New York in 1999. He's worked with the People's Republic of China during the 2003 SARS outbreak and currently advises the Kingdom of Saudi Arabia in addressing the challenge of MERS. He's also engaged with ICMR on working on encephalitis in Gorakhpur. And of course, he was also the chief scientific consultant for the film Contagion. Ladies and gentlemen, please put your hands together for Dr. W. Ian Lipkin on The Diary of a Virus Hunter, cutting-edge research on cancer, encephalitis, autism, fatigue, and just about everything else. Dr. Lipkin, can we have you on stage, please?
Thank you very much for that generous introduction and these beautiful pictures. My talk today is going to be really at 10,000 meters because I don't have a lot of time. I'm going to try to cover during the first part the ways in which we recognize and appreciate infectious agents, not only as causes of acute disease that we recognize as infectious, but also some of those where it's more difficult to make the connection, like autism and cancer. And then I'm going to spend the second portion talking about viruses in a different way, thinking about social media and the ways in which we can use models of infectious diseases to understand political instability, racism, hatred, and so forth. So I've never shown that particular part before, but it interests me more and more, and I think it's very important, and I think there are lessons from infectious diseases that will be helpful. This is a slide which illustrates all the things we work on. We're best known for virus work in our center, but we work with bacteria, the microbiome, fungi, and other infectious agents as well. This is from the cholera outbreak in London in the 1850s. And the person who was key in resolving this problem was John Snow, who is probably, in my field, best known for his work in epidemiology, but many people know him as the one who gave chloroform to Queen Victoria during childbirth. And in fact, he's as famous for that as he is for his work in infectious diseases. And the new program that you have in India, which is installation of toilets and so forth, really dates back to thinking about these sorts of fecal-oral diseases that are so important. What we now use, of course, is modeling to try to figure out where infectious agents are likely to emerge based on changes in population, deforestation, contact with animals, and then we bring sequencers to bear. And this is an example of one such sequencer. When I first began this kind of work, I was still in training at that point at the University of California at San Francisco when HIV/AIDS first appeared, and we didn't even recognize the agent for some 2 years. So I invested several years of my life trying to develop new genetic methods that are rapid and powerful that allow us to sort this out. And these are some examples of some of these platforms including a very small one there that can go into a USB port. I've been coming to India since 1997, initially working at the International Center for Genetic Engineering and Biotechnology. And one of the things I would very much like to persuade you of today, technologies that I'll be describing are straightforward. And there is no reason that with a very small investment, India could have a surveillance system on par and perhaps better than anywhere else in the world. And if there are any philanthropists or ministers who would like to talk about how to do that, I would be very happy to meet with you during the conclave or afterward, because the time has come to address these sorts of problems. So we've discovered over 1,500 viruses. We don't even count them anymore because there are so many of them. And they're very important viruses. 10% of them, I would say, have implications for human health or for food security. The methods have become so robust now that within a period of 24 hours, for about $200 US, we can take an environmental sample, a sample from an animal or a human, and identify the agent. This is not only true with viruses, it's also true with bacteria. We can also identify antimicrobial resistance patterns that allow us to select the appropriate antibiotic. And within the next 10 years, I'm sure that when you go in to see a physician with an infectious disease, that physician will be able to tell you very rapidly not only what you have, but how it should be treated, very specifically. This is going to reduce healthcare costs, it's going to prevent pandemics, it will be very powerful. The other thing that we've transformed, I think, is the way we think about infectious diseases by focusing not only about detection of an agent, but looking for footprints after the agent is gone. So we can find small molecules called antibodies that are present long after the agent is no longer detectable with molecular methods, even those that are very robust. And we can say this is linked to cancer, this is linked to autism, this is linked to chronic fatigue syndrome. It's a whole host of things that we can try to understand. And I'm only going to be able to give you a couple of examples. The most poignant example I'm going to show you has to do with this recurrent outbreak of encephalitis in Gorakhpur that we see perhaps every 2 years. And you're more familiar with this than I am, but we were invited 2 years ago, almost to the day, by Soumya Swaminathan, who was then the director of the Indian Council for Medical Research, to come in, to go to Gorakhpur and to try to collect samples from these children. And I will tell you that it's a heartbreaking situation when you see that you need a new building because there's so many children who are affected. And every time you have flooding, you have fleas that go from these animals that move on to these children. And we were able to identify the cause by using some very sophisticated molecular and antibody techniques, all of which should be here in India, but you don't have them for reasons which I don't understand. The most important of those were these two bacteria, Orientia and Rickettsia. Each of these targets can be treated with tetracycline drugs, very inexpensive drugs. There were also some viruses that were important too. These methods will allow you in an outbreak to figure out how these children are sick and what the appropriate drug would be. More recently in the United States, we saw a disease that looked like polio. We were unable to detect the agent using our genetic methods. By using antibodies in spinal fluid, we implicated a virus, an enterovirus called EVD68, and now we're beginning to make various vaccines directed against this particular bacterium. The other thing I'd like to stress for you is the importance of using these techniques to try to understand whether or not there's an infectious basis for some disease that we don't typically think of as being infectious, like diabetes mellitus or obesity or autism or schizophrenia. And here it's a function of looking at the genetic background of the individual, the infectious agent, and the timing of exposure. The best approach to doing this is to employ what's called a cohort. So you start studying people when they're well, you examine them on a regular basis, and when they develop a disease, you're able to go back and ask whether or not the exposure histories were different. This is a program that we've done with the government of Norway that's focused on autism and attention deficit hyperactivity disorder. And what we found when we looked back at the history that was taken in advance, so there was no subjective bias, we found that if women had a history of fever after the 12th week of pregnancy, there was a threefold increased risk in that child being diagnosed with autism. When we tried to figure out why they had fever, we identified some of these women had a history of herpes simplex, a sexually transmitted disease. Others had influenza virus. It appears not to make any difference what the agent itself might be. It's the response to that agent. This means, therefore, that we can't prevent the infection. Maybe by suppressing inflammation, you can prevent this disease. So this is not only good for public health, but it's also good economically because you save hundreds of millions of dollars annually. Now, the dark side of pathogen discovery is that if you're not careful, you can wind up making links that aren't real. About a decade ago, Andrew Wakefield at the Royal Free Hospital in London published this paper suggesting that children with autism had been infected as a result of receiving MMR vaccine. And as a result of this spurious link, which we disproved unequivocally, many people who were very, very prominent took to media and said they believed it. Bobby De Niro, Donald Trump, a number of other people who were less well known, and as a result, people stopped vaccinating their children against measles. There's been a big spike of measles in the US as well as globally. And these changes occur not only in people who are less sophisticated, but frequently in people who are more sophisticated, but who get their information from the internet. And this anticipates what I'll talk about in a moment. In March of 1999, I was invited to attend a conference that was led by the Department of Defense. And there was a plant virologist, an animal virologist, and a computer virologist. And in 1999, people weren't talking about worms and Google and all of these other things, but they anticipated that this was going to be a problem. And here is some interesting data. The whole concept of going viral is really quite new. The earliest citations date back to 1989, when people were talking about the concept of going viral in terms of thinking about advertising. How do you sell a product? In 1 minute on the internet, there are 188 million emails sent, 4.8 million graphics, 4.5 million videos on YouTube, search queries, Facebook logins, and so forth. Twitter has 330 million users. Donald Trump has 64 million followers. Modi has 50 million. These are people who get their information, which may not even be quoted accurately. Facebook, 2.4 billion users. Instagram, more than 1 billion users. 2/3 of the users are youngsters, less than 34 years of age. WhatsApp, more than 500 million users, and growing all the time. YouTube is perhaps the most powerful of all. 94% of people 18 to 44 years of age in the United States use YouTube on a regular basis. It's considered the new television, probably the most important medium. Children turn to YouTube for content. This is where they get their information. And people have recognized that YouTube can frequently be the entrance to the dark side of the internet, where they get misinformation access to drugs, all sorts of things, as well as the anti-vaccine movement, which has been promoted via these social media, and Brexit, and hatred, and intolerance, and all sorts of things. Now, how do we fight back against these sorts of things? Now, when I was introduced, this wasn't emphasized sufficiently, so I'm going to talk a little bit about it now. About 10 years ago, I began working with media, with gamers, with filmmakers, to try to ensure that the information that was being transmitted by films was not only entertaining, but accurate. I initially began with Contagion, which has been recognized as being a very sort of accurate movie. More recently with Bond 25, where I've had less control. Plague Inc., which is a game. 3 Months, which is the story about a young man exposed to HIV. And Utopia, which is about an influenza outbreak. The other thing that I've become very interested in is the concept of vaccination. You can actually vaccinate people against hatred, gun violence, and so forth. And one of the pioneers in this field is someone in the United States named Gary Slutkin, who has gone into areas characterized by gun violence, has gone around these areas, identified people who are at risk for moving into gang violence, and has found ways to talk to them, to move them back toward middle ground, to enhance tolerance, and so forth. And this is one of the things that I think we need to do, is to use this ring vaccination strategy, which was first employed for control of smallpox. But we can actually use this now to control hatred, intolerance, ignorance, anti-vaccinations, and so forth. So before I take your questions, I just want to highlight a few points. The first is that we have new methods for identifying infectious agents, directly as well as indirectly. So we can find cures for chronic diseases that plague us. Virology provides lessons for the digital era. And that's why I was alluding to these issues with respect to gang violence, hatred, and the increasing importance of Google, WhatsApp, YouTube, and others. So if we're going to survive as a human race, we're going to need to address not only infectious diseases as we traditionally think about them, but also as we think about them in a larger context, as the viruses that are infecting our social life. Thank you very much. And I wanted to leave a lot of time for questions, and I hope there will be some. Please.
Any questions from the audience? Do we have some? Yes. Can someone please hand a mic over to that gentleman over there? And if you could please introduce yourself, sir. The gentleman over here, front row. Yeah.
Hi. It was a pretty interesting session. I'm Jay Kishan from ITC, and the question I have is, I would like to know a bit more about how virology can...
Can we turn up his volume? I can't really hear.
Yeah. Is it audible now?
Great.
Yeah. Okay. Yeah. Okay, the question I have is, I would like to get a bit more understanding on how virology can be used and implemented in media to reach out and talk about the outbreaks of certain viruses and how to kind of have a control over it.
Make it out. What was the question?
Can you please repeat your question?
I just wanted to understand how virology is being used in media and what would be the outcome of it when you try to kind of have a solution.
How virology is being used in media.
So the question, I want to make sure I have it correct. I was talking about the way in which you move from...
Can you just,
the way in which you move from viruses as physical constructs into thinking about how they infect, how the impact is on social media. Is that correct? Okay, so the idea, and this really began, this is not an original idea of my own, but there was a recognition that things like gun violence, the use of opiates, sexual mores and so forth, all spread like infectious diseases. So the way in which this is being done, treated, and so forth, initially is with education. We try to communicate through traditional media, games, movies, televisions, and such ways in which people can understand the risks that are associated with some of these kinds of social constructs. And in addition, if we can identify where this is a problem, you can actually go into communities, speak to people who are in these areas where we see violence and hatred, and we can actually have conversations with them. These sorts of things actually, in India, make a great deal of sense, because this is, in fact, how you got your liberation, was by having these sorts of people who would speak to others, who would speak to others, and eventually you would get this whole group that would be moving up behind a common leader. I hope I answered your question. I'm not sure that I did.
Doctor, my name is Raj Chengappa, and can you hear me? Yeah. I'm with India Today magazine. My name is Raj Chengappa. I had two questions. One was, you had mentioned that in your study that autism, the parents that had an autistic child, the mother had fever during pregnancy, and therefore you found a correlation between the two. Have you been able to then therefore offer a cure for that particular problem? That's my first question. My second question is
I'm not very smart,
okay,
so I have to do them one at a time.
Sure. I'll wait.
I'll take the second one, of course.
Sure.
So the question really was, if I get this correct, is how can we use this information about the risk associated with infection to result in some sort of way in which we can reduce that risk? So the risk that I showed you was modest. It was an odds ratio of 3, which means that the risk of a mother who has this infection goes up 3-fold if she has an infection during a certain portion of pregnancy. We use this as an argument to say this is why you need to be vaccinated against influenza during pregnancy, as one example. Some people are using this as a way to say if you have a history of herpes simplex type 2, you should be placed onto prophylactic anti-herpes virus therapy during pregnancy. This is not to say that all autism is due to infection. I'm not saying that. I'm saying that some portion is. And when you start looking at diseases that are complex, like autism or schizophrenia or diabetes, what we find is that there's a whole spectrum of disease. With diabetes, we found that enteroviruses, for example, frequent enterovirus infections during early life are associated with increased risk of insulin-dependent diabetes. Why might this be? Because if you stimulate the immune system, you elicit autoantibodies. That's one mechanism. Another is simply that there are cells and circuits that are vulnerable as they develop, and they then wind up making the wrong connections. So there are a range of ways in which this can work. The initial observation is statistical. We have animal models where we have been able to prevent disorganization of the brain by using anti-inflammatory drugs. We've only done this so far in rodents, and until it's done in non-human primates, we would not recommend it for humans. That is where the work is probably going to go. And your second question, sir?
Hello? Yeah. My second question was your study on in Uttar Pradesh about Japanese encephalitis, and you seem to have identified a bacteria, virus. I'm not sure which one you had identified. Why didn't we move towards then curing this rather than having the kind of number of children that died in Uttar Pradesh?
So the question is, the etiological agents responsible for the encephalitis outbreak, the AES in Uttar Pradesh, since this has been going on, which is about 15 years now, first it was thought to be Japanese encephalitis virus, then it was thought to be dengue virus. More recently, we have data that suggests that it's these two bacterial infections. The lesson here is that there are risks from all of these agents. If you have the ability to rapidly diagnose these infectious agents in an outbreak, we can then prioritize treatment and find ways to prevent disease. So again, anyone who has influence, please come find me. I would love to set up surveillance here so that you can do everything that's done in the finest laboratories in the world. We did this in China, we did it in Saudi Arabia. India deserves no less.
All right, we only have time for one last question.
I was hoping a woman was going to ask a question. It was time.
Well, I'm glad to be able to do that. Doc, thank you so much. It's such a fantastic, fascinating presentation. My question is, are there good viruses or are they just all bad?
That's a great question. So the question is, are there good viruses? I will give you an example of a good virus. So the evolution from egg-laying animals to live-born animals, right, which required the development of a placenta, was facilitated by good viruses. These are known as endogenous retroviruses. They came into our chromosomes millions of years ago when we first had mammals, and what they do is express a protein on the outside, which is normally present on the outside of a retrovirus, that suppresses the immune response, because an embryo growing within the womb is essentially a tumor. It's a foreign body. So without these good viruses, we would not have mammals. So that's a good virus. Thank you very much.
Thank you. Thank you very much. Can I request you to stay on stage, sir? Professor Lipkin, can we request you to stay back on stage for just a minute? We'd like to thank our session sponsor, Kokilaben Dhirubhai Ambani Hospital. And can I please invite Mr. Shenik Mehta, Assistant Vice President of Kokilaben Dhirubhai Ambani Hospital, to please come on stage and present our guest with a token of our appreciation. Once again for that very insightful conversation. With that, we move on to our next session, sponsored by Hyundai. Power Rangers meet the social media icons shaping India's youth psyche. Can I please invite Ajay Nagar, YouTube roaster named by Time Magazine, and Prajakta Kohli, a YouTube comedian, Indian ambassador for YouTube's global initiative, Creators for Change, and my colleague Sushant Mehta, entertainment editor, India Today, on stage, please.